So this proportion that you see here on the screen where I've got sector over total area equals x degrees over 360 degrees. In a situation like this, you might say, I don't really see how this helps me that much. You'll see if we do the example here, right? You just say to yourself, let me go through the proportion, and whenever I know a piece of information, I'm going to put it in its appropriate spot, right? Here, 8.3 meters, that's going to help me find the area because I'm going to use pi r squared for that. I'm going to do pi times 8.3 squared, right? So this is, again, just to find out what goes in this spot here. So I go in and I ask my calculator, what is 8.3 squared? And it'll tell you that that's 68.89. So you have 68.89. And you got to multiply that by pi to get the total area of the circle, which ends up giving you 216.42, in this case, meters squared, right? So that's the total area of your circle. So that means, good, now that I know what A is, using this piece of information, using the radius, I can put that number in here, 216.42. And then this 360, that always goes here. That's the easy one. That's the given. I look in the diagram, I got 165 degrees. So 165 degrees goes in the spot where the central angle always goes. I got that spot up here, right? That's x degrees, that goes here. So I got 165 in this spot, 360 down here. Got the area of my the total area of my circle here, and right here's the sector area that I'm looking for. Since I've set it up as a proportion, I know what that means. I know that means I can do a little fish method here, a little cross multiplication. So 216.42 times 165 divided by 360 will give me the area of my sector, which in this case is 99.19 meters. 99.19 meters squared is my sector area. Okay. Now you're looking at this and you're saying, well, I mean, what we did before was we just did pi r squared with this. And then, here you're writing 216.42 times 165 divided by 360. That's just the same thing as what we're doing before. And you're right, of course, because you're astute and you made a good observation here. But the reason why I want you to learn this proportion, this one here, burn this into your brain, sector over area equals x over 360, sector area over total area equals central angle over 360, is that when you run into a situation that's a little bit more complicated, then the proportion can help you out. Like if you look at this question here, example 3a, notice that it doesn't give you the radius, right? You've got a sector area question where you don't have a radius, and you're supposed to figure a way out of this, right? Notice the question's actually asking you to find out what the radius is. And so in order for this to work, you're going to have to work backwards. And to work backwards successfully, you're going to want to use that proportion. I'm going to write it here again. Sector area over total area equals central angle, which is x degrees, over 360 degrees. So here I don't have my area. This one here is going to be blank, right down here in the bottom left. But I do know that 360 always goes here. I can put that there. I look at the diagram. It gives me a central angle of 230, so I can fill in this spot here. And for sector area, it gives me the area of the sector is 82.7 centimeters squared, so I can fill that spot in. And now, again, I've got a nice proportion set up where I'm trying to find a missing spot. So what does that mean that I have to do? It means that I'm going to use the fish method. I'm going to do 82.7 times 360 divided by 230 to find out what goes there. So times 360 divided by 230, and that tells me the total area of the circle, which I'm going to write here. The total area of the circle is 129.44 centimeters squared. Now the question isn't asking me to just find the area here, right? I'm doing all this, I'm using this nice proportion here because it's going to help me get to the final answer, which is the radius. But by now you know that if you have the area, it's not too hard to find the radius, right? First thing you got to do is you got to say, okay, well, if area is equal to pi r squared, let me divide this guy by pi. And then once you divide this by pi, you're left with 41 point, you're left with your r squared, which is 41.20 is the closest to 2 decimal points. And so if you square root that, you will end up with your actual radius, which ends up being 6.42. R equals 6.42 centimeters in this one, rounded to the nearest hundredth. Okay, let's do another example like this just to see. I look and I see the information I have here. I got a sector area. I got a central angle. I don't have a radius and I'm being asked, this is the same question here, I'm being asked for a radius. So I set up my proportion and I fill in the spots with the information that I know. 360 always goes here. I have a 9.2, that's the sector area. Sector area I'm going to put on the top left. I got a central angle of 41 degrees. I'm going to put the central angle on the top right. That means I got one spot open, which in a proportion is fine, because I can always find the missing spot if I have 3 of these other spots filled in. The way I do it, 9.2 times 360 divided by 41 will give me my 80.78 that I'm going to put here. My total area is 80.78 meters squared, right? That's 9.2 times 360 divided by 41 gives me 80.78. And then if I want to find the radius, I know that area is the same thing as pi r squared. So if pi r squared equals 80.78, let's divide both sides by pi here. We're going to divide both sides by pi, and that'll tell us what r squared is. So 80.78 divided by pi gives me 25.71 meters squared. And then in order to find out what the radius is, I square root this guy, I square root that guy, and that way I find out that the radius is equal to the square root of 25.71, and that's going to give me 5.07 meters, and that is the radius of my circle. So despite the fact that I didn't have a radius, I was able to get one by using that proportion. Little twist on it here, I'll do one of these examples with you. In this case, look and see what information you do have and what information you don't have and what it's asking you to find. Here it's telling you to find the central angle, calculate the measure of the central angle, find the number of degrees in the central angle based on knowing the sector area and the radius of the circle. So again, you say to yourself, all right, let's figure out what I got here. I got 360 because he's always here, the 360. Central angle, don't have that. That's what it's asking me for, so that's our question mark right now. 67, that's my sector area, so he goes in the top left because that's the sector area spot. And then the 8, well, I can't just write 8 here. Well, that's a common trap people fall into. 8 isn't the area, right? This spot is reserved. This parking spot is reserved for the area. So first I have to turn this 8, this piece of information that the radius is 8, into the area, right? And area is pi r squared. Here the r is 8, so I can just replace the r with 8, and then I can figure that out. 8 squared is 64, so then I get out my calculator, I type in 64 times pi, and it tells me that that is, the area of my circle is 201.06 centimeters squared. Okay, so I thought I only had 2 numbers here. Now I can put the 201.06 in here, and when you got a proportion and you got 3 of the spots filled in, you can always find the 4th one. You do 360 times 67 divided by 201.06. So 360 times 67 divided by the answer I just had to the previous question gives me a central angle, the number of degrees here, x degrees equals 119.96 degrees. And that's my central angle. Again, even though I didn't start off knowing radius and the angle, I was still able to find my answer to the problem because I used this proportion here. So remember this proportional right here one last time. Sector area over total area equals x degrees, that's your central angle, over 360 degrees. And if you can remember that, then you'll be able to get through all of these problems dealing with sector area.